All right, here we are. This is video 11.2.3. It is our last video for the standard. And we are going to be working, still trying to solve our systems of equations, but this time we're going to be looking at some special cases and using something called RREF. And it's a method that we can use to solve to solve any system, but it actually differentiates our special cases for us. So let's go ahead and get started with it. All right, so our special cases are when we end up with an inconsistent system or infinitely many solutions. So if we end up with an inconsistent system, as in it's not leading us anywhere, it's not going to give us a solution, as in parallel lines, just to remind ourselves, or infinitely many is when it's exactly the same line. So let's go ahead and, oops, this should be an equal sign. I don't know what happened there. Let's go ahead and solve the system using just our thoughts, like how would this work out? What would happen if we were to multiply this whole top one by -2? And we would see -4x, we would see, if I distribute here, a +6y, but then we would see -20. So I would see the left-hand side go to 0, but the right-hand side not. So this is going to lead us to parallel lines. That's what we have in this system. It's inconsistent. On the other side, if we were to multiply everything by 4, we would see, we would see that everything canceled out and we got 0 equals 0, which is true. Oh, I cross it off, which means we have infinitely many solutions. So these are our two special cases, and 2x2s are pretty simple to solve to get the conclusion and then know exactly what it means. But what happens when it's not so easy of a system with 2x2s? Maybe there's decimals, maybe there's more things going on. Or we have a 3x3 system. So we're going to be taking a look at this one, which I could figure this out by using one of our simple methods of elimination or substitution, but I don't want to. So I'm going to show you a way of using RREF and augmented matrices. And RREF stands for reduced row echelon form. Just so you know what it means, that's what it means. Reduced row echelon form. Now, how are we going to enter this? We're actually going to use what's called an augmented matrix. Okay, so I'm going to make one single matrix that is going to have the coefficients. And then when you write this on paper, we often write this vertical line here. It's not shown in the calculator, but that's how we would write it on paper. It's a vertical line, and on the other side are the constants. So we actually take this, which would have been a 2x2 and a 2x1, and we're actually going to enter it as a 2x3. That is that we still have 2 rows, but we're going to have 3 columns. So I'm entering 1.5, 4.2, -1, 12, 32.6, and -8. Now, when you enter this in the calculator as a 2x3, okay, this is all going in as matrix A, you will not see that vertical bar. It will just look like a 2x3 matrix. So go ahead and pause the video now and just enter this. That's all you have to do, and then unpause the video. Alright, so matrix A has been entered. The next thing you're going to do is press second matrix and arrow over to math. So it's second matrix, which is the negative inverse sign. Okay, and then you're going to press arrow over to math. Okay, and then I want you to arrow up until you see RREF. Now, there is an REF, which is not the same thing. I want you to use RREF, and it'll have a parenthesis. So arrow up to that one, and then now you're going to call matrix A to the home screen. So you'll see this, and it'll have the little box, and it'll say matrix A. And then go ahead and press enter. And what it shows on my calculator screen is that you can't really see everything. It gives you the dots. So if you press math enter, you do get fractions. And this is the result. You get 1, 0, -2/3, and then you have 0, 1, 0. Okay, Okay, so this is what you end up with. Well, since we have an identity matrix right here, and I do have the identity matrix, that means that the leftovers are your solution. But you have to see the identity matrix. If you do not see the identity matrix, then we have one of our special cases. So here we have negative 2/3, comma 0 as the solution to this system. Okay, so we're going to set up our RREF form, our augmented matrix for this system. The one thing we have to notice is that this -5 is on the wrong side. So it has to be added over to the other side before we can use the augmented matrix. We want to make sure it's set up in the correct way. So let's go ahead and enter that in. I'm going to write it down. It's 2, -3, 4. I am drawing the vertical line because that's how it's written on paper, even though you won't see the vertical line in the calculator. 6, -9, 12, 24, 1, 2, -3, and 5. So now this is going to be entered as 3 rows times 4 columns. So it's always the columns that change. It would be a 3 by 3, except I'm adding the extra column. So that's why it's a 3 by 4. So please put this in the calculator, and then we're going to do the RREF, which was found under second matrix. You have to go over to math, and then arrow up until you see RREF, and then enter in matrix A on your home screen. So pause the video, and then let's see what results we get. Join me in a second. Alright, so when I did that, and I also turned it into fractions because it was too large to be seen on the home screen, is when I turned it into fractions, I got this matrix: 1, 0, -1/7, 0, 0, 1, -10/7, 0, 0, 0, 0, 1. When you get this, you should first notice that I do not have a 3 by 3 identity matrix. In this position right here, I should have an identity matrix, but I do not have an identity matrix, which then tells me that I have a special case. And the special case could be that I have all solutions, that these three-dimensional lines are actually lining up on top of each other, or that they are parallel to each other and they will never intersect. Now they could be parallel in the plane, or they could be parallel in all planes to each other, but what they're saying is that they're not intersecting, or that they're all the same line. So one of the special cases is being had. And what I can see from the bottom row is that this right here is inconsistent, that there are no solutions, and that's because there's a 1 in this position. Okay, so this is no solutions. Alrighty, let's go ahead and take a look at the last example. Alright, so I want you again to set up your augmented matrix, and you can check back with me to make sure that you typed it correctly, and then we'll proceed to use RREF, and after that we'll draw a conclusion based on the matrix that it outputs for us. So pause now. Alright, so hopefully you got this matrix, so go ahead now and enter RREF and call that to the home screen, and maybe turn it into fractions as well. So go ahead and pause now. Alright, so here we go. I'm going to write down the resulting matrix, which actually, even after turning into fractions, was really difficult to see on the home screen, that I did have to actually arrow over just because of the fractions that were involved in this one. So I'm writing it down with you. Oops, that should be 31 over 11, and then 2 over 11, and then the bottom row is all zeros. So once again, I do not see the identity matrix, which means that I do not get a normal system solution for this one. And what that leads me to believe is that there must be something special about this bottom row. And this means that these are inconsistent, which means that we have excuse me, I said inconsistent. Infinitely many. Okay, so we end up with all zeros on across the bottom, so we have infinitely many solutions. So in the 3D model that we would have to align these XYZs in the 3 different planes, these would be parallel, they would never intersect. And that doesn't mean that they're all going in the same direction. It means that in the planes that they would be parallel and they would still never intersect. So that is our final conclusion. So this RREF method takes you to look at the whether or not you have an identity matrix, which would provide the actual solutions, or if you do not have an identity matrix, what does the bottom row tell you? All right, you guys, great job with these.